Hello again, my name is Brandon Clayton. I am the Algebra Guy. Today we'll be discussing prime factorization. What is it and why is it necessary? So the title here is Find the Prime Factorization of a Composite Number. Last lesson we talked about the difference between composite and prime numbers. Please be sure to check out that lesson if you're confused about the vocabulary. By the end of this lesson, you'll be able to answer questions like this. What are the prime factors of 36? What are the prime factors of 36? So let's jump into it. Today we're going to answer these questions. What is prime factorization? What is prime factorization? How do we use the factor tree method to find the prime factors? How do we use the ladder method to find the factors? So let's jump into it with the first question. What is prime factorization? Prime factorization is a number. The prime factorization of a number is the product of prime numbers that equals the number. What? Well, that's just simply saying, let's take a number and break it into all of its prime numbers so that when you multiply them, you get that original number back again. So let's try this for instance. Let me get out my pen. All right, we'll start with blue. All right, so let's say this. We could take this 36 and let's just divide it to any two factors. Let's say I know that 4 times 9 gives me a 36. So 36 and 4 times 9, they're the same thing. But I'm going to keep going with this tree until I can break it down into prime numbers. 4 is not a prime number because you have more than just two factors. And 9 is not prime because it has more than two factors. So let me keep breaking this down even further. So I know that 4 can be accomplished by multiplying 2 times 2. 2 and 2 are factors. So what I'm going to do is circle, put a little bud on this tree, if you will. Just like they're budding about the plant. So when we see that circle, we know we're done with that side of the tree. Let's go back to our 9 now. I'm going to change colors here. And we can break our 9 into 3 and a 3. And I can't go any further, so now I have my factors, my prime factorization. All these are prime numbers. Now I know the prime factors for 36 is 2 times 3. 2 times 2 times 3 times 3. That's really how you do it. So using the factor tree method is one way you can do it. I want you to practice it now. I'm going to erase this one and give you one to practice. And I'd like you to pause it here and see if you can answer this question. Find the prime factorization of 48 using the factor tree method that I just showed you. Why don't you pause it here and try it yourself? All right, if hopefully you've done that, I'm going to go ahead and draw 48 at the top of my little tree here. 48. And we're going to start branching off. It doesn't matter which two numbers you start out with, by the way, as long as eventually you get down to some prime numbers. Now, you could be kind of sneaky here and start with a prime number, which is 2. And you already have one of your buds. So 2, and this will break down to, what's 48 divided by 2? 24. So I already have one of my buds here. Buds, not but, buds. So breaking that into, we're going to break this 24 into two factors. What two numbers can I use to multiply to get 24? It doesn't matter again because eventually we're going to get the same answers. But my first thought went to 6 times 4. Are either one of those primes? Nope. So let's keep going. So we're going to keep breaking down this 6. 6 can be broken down to a 3 and a 2. And I do notice that 3 and 2 are primes because only 1 times 3 will give you 3, and only 2 times 1 will give you 2. So they only have 2 factors each. And 2 times 2 will give me 4, and I know that 2 is a prime, so I can circle those. So now, if someone asks me, what is the prime factorization of 48? I can tell them it's 2 times 3 times 2 times 2 times 2. So I got 4 2's and 1 3. If you multiply all those prime numbers, you get, you guessed it, 48. There's one other way you can use that you may enjoy and like better. This is called the ladder method. Not the ladder as in I'll do this, I'll do that later or later, but a ladder method as if you're climbing up the rungs of a ladder. So what you'll do is you'll take the smallest prime factor you can think of to divide a number. Let's start with our 36 again. So we're going to start with 36. So the smallest prime we can divide 36 by is 2. Well, 36 divided by 2 is 18. Okay, so what are we going to do? Well, we're going to continue to divide by that same prime number. So we're going to continue to divide by 2, but this time we're going to divide 18 by 2. Well, 18 divided by 2 is 9. And we're going to continue to use that same number, but we can't use 2, can we? Because 9 divided by 2 won't work. So we're going to use the next one up. What's the next prime number up? That'll be a 3. So 3 times 3 gives me 9. And there's nothing else I can do from here. Actually, I could divide another 3, right? 3, and that'll give me 1. So now, if you look right here on the edges of that ladder, 3, 3, 2, 2. You notice we found our prime factorization. So that's another way you can use to find prime factorization. Remember, we used our ladder earlier to do that, and it gave us those same numbers. Whether you start with 218, there's 1 there, and we could break this into 9 and 2. That'll give you, there's 1 there, and 3 and 3. 3 and 3. So notice we got 2 3s and 2 2s, no matter how you do it. Whichever is comfortable or easy, but it's nice to know you can do it multiple ways when checking your answer. So let me give you a problem so you can check to see if you got it. 120 using the ladder method. So we're going to start with the smallest. I'm going to start at the bottom here because I know we're going to build up our ladder. 120 divided by, we're going to start with the smallest prime, which is 2. And I'm going to do blue to make sure we can see our factorization really easily. So 120 divided by 2 is going to give us a 60. 60 divided by 2, we're going to keep using 2 as long as we can. It gives us a 30. And 30 divided by 2 gives us a 15. And 15 divided by 2, oh, wait a minute. We can't divide 15 by 2 because it doesn't end in 2, 4, 6, 8, or 0. So we need to go up to the next number, prime number, which is a 3. 3 goes into 15 5 times. And can I go any further? Well, I can't divide 5 by 3. So let's go up to the next prime number, which is not 4, but yep, you guessed it, 5. I need to use blue there. 5. So 5 divided by 5 is 1. So if I were to circle all of my prime numbers, look at that. There it is right there. That's how the ladder works. So all your divisors will be your prime numbers. Let's check if this makes sense. 5 times 3 is 15. 15 times 2 is 30. 30 times 2 is 60. 60 times 2, yep, is 120. So I can multiply all my prime numbers together and still get this. So that is how you do it. I think that's it. Let's review and see if we covered everything we're supposed to. What is the prime factorization? We answered that question. Did we find out how to use a factor tree? Yep. Did we find out how to use the ladder method? Absolutely. So we did all 3 of those. We have accomplished our goal. Thank you for tuning in. I'm Brandon Clayton, the Algebra Guy, and I will see you next lesson.